Good morning, my dear students. Today we are going to learn a fourth problem in the machine design. Okay, a structure is subjected to loading condition as shown in a figure. Calculate the maximum normal and shear stress we need to find out in this equation. Let us see. A structure component is given. The one end of this component is rigidly fixed. Okay, and on the another component the some amount of forces is acting. Another one is the axial force is acting as 9000 Newton. Okay dear, and then the torsion moment or torque is acting as 100 Newton meter. Is it right? And then the length from the axis from A to B is given as 28 mm is given. Okay dear, the first thing is the structure component several force is acting like axial force, okay, bending force and torsion force. Okay dear, let us see. So first of all we are going to apply the axial load. A condition, axial load. First of all we need to draw the free body diagram of the axial force. One end is fixed, okay, they having two fibers, one is A and B. Okay, so A is acting as tensile force, B is acting as a compressive force. Here axial load is acting as 9000 Newton. Okay, the diameter of this force is how much is there? 50. So if we apply the tensile load, then what will happen here? Then A and B will be elongated. The A and B will be goes down, increases if we apply the axial load on the specimen. So which force we applied here? Tensile force we applied on the specimen due to the sigma A and sigma B will be elongated. Okay dear, let us see. Sigma A. So sigma is indicate that axial stress is acting at A should be equal to axial stress is acting at B equal to, because the same load will be increased, because if we apply the tensile load what will be happened here, the both A and B gradually increase. Is it right? So for that reasons I represent as axial stress is acting at A should be is equal to axial stress is acting at B. The formula is force per unit area. The unit of force is how much is there? The force is 9000 Newton by area is pi by 4 into d square. Okay dear, so diameter value is how much is there? Sigma A equal to sigma A capital B equal to 9000 into 4. It will move above numerator value pi. What is the value of d? The d value is 50, okay, into 50 whole square. Then you will get the answer with the help of calci. So I am getting the answer is 4.58 Newton per mm square. Okay, we found out the value of axial load. Again what we need to find? We need to find out the bending load. We need to find B, bending stress. Okay, so bending stress, if you want to find out, then you have to know about the bending stress where they acting here at A is equal to M by ZB. Let us see the figure. Okay, this is fixed end. They are having the two fiber A and B. A we can say as outer fiber, B we can say as inner fiber. On the outer fiber the tensile stress is acting. Okay dear. On the inner fiber the compressive force is acting. If you want to draw the free body diagram or distribution diagram, let us see. This is your axis. So here this one we can say as fixed end, and this one we can say as free end. Okay dear. Above what we can say here? Above we can say as outer fiber. It is acting in the tensile nature. B we can say as inner fiber. They are acting as compressive nature. Above it is acting as tensile nature. So what we can say? Outer fiber. So below what we can say here? Inner fiber. So what we can say? Compressive nature. So what is the nature is there? Compressive nature. Let us see. If we apply this some amount of bending load, due to the what happened here, above it is expandable. If it is expand, what we can say? Tensile force is acting at a point of B. At a point of B, which force is acting? Compressive force is acting at a point of B. So is it right? So B what we can say? Inner fiber. A we can say as outer fiber. Is it right? So for that reason you have to know how much it will expand. What is the length from expandable? You have to know how much force you applied due to it is expandable. How much force you applied on the beam due to the body is expandable. So we have to know about M formula is force into L. Okay, pi d cube by 32. Okay. Sigma BA is equal to force. How much is that here? We applied the force of bending load. We have to know is force we applied how much? So we applied the force of how much here? Here 9,000 Newton is acting. Is it right here? Then you have to represent force is we applied on this overall beam. Length is how much is there? Length is 28. Okay, pi by 32. D is how much here? The diameter is 50 whole cube. If it is move above means sigma BA is equal to 9,000 into 28 into 32 by pi into 50 whole cube. Then you will get the answer with the help of calci. So I am getting the answer is 20.53. How much I am getting here? 20.53 Newton per mm square. So I am talking about at point A. At point A. Again what we need to find? At point B. Okay, at point A as well as at point B. At point A, which force is acting here? Positive. Positive nothing but tensile force is acting. Okay now? Again, B. On B, which force is acting here? Compressive force is acting. Then you have to represent at B bending stress at point B. Okay dear. So we need to find out bending stress at B equal to M by minus M by ZB. M is value is how much is there? Minus force into length by Z means pi by 32 into d cube. Okay dear, let us see sigma b b. So this indicates that bending stress at b equal to, force is how much is acting? So force is 9000, length is how much dear? 28 by pi by 32 into diameter is how much is that here? 50 whole cube. Okay dear, I will drop this one. Sigma BB equal to minus 9000 into 28. If it is move above means it should be 32 pi into 50 whole cube. If you calculate by the calci, then you will get the answer is how much? Minus, you will get the answer is 20.53 Newton per mm square. So this means that this minus is indicate that the compressive force is acting at a point of B. Okay dear. Again we need to find out the torsional stress, or we can say as twisting moment we need to apply. So C point, torsion stress. Okay dear, if you want to find out the torsional stress, you have to know about the formula is tau is equal to T by ZT. Okay, so T, torque is how much we applied here? We applied the torque of 100 Newton meter. So this means that you need to convert in meter means 100 into 10 power of 3 Newton millimeter. You can represent. So here 10 power of 3 Newton mm you can represent. If you want to remove the meter, is it right? So let us see over here. T value is 100 into 10 power of 3 pi by 16 into d cube. Let us see again, 100 into 10 power of 3 into, if it is move above means it should be 16 pi, diameter is how much is given here? Diameter is given as 50 whole cube. Then if you calculate by the calci, then you will get the answer is, so I am getting the answer is 4.07 Newton per mm square. Let us see how to draw this torsional stress diagram. Okay, this is beam. On beam we applied the torque. How much dear? 100 Newton meter. Is it right? If we applied, then what will happen here? If you consider this circular cross section, this is the portion A and B. On portion A, it is acting as tensile stress. On portion B, compressive stress is acting. A, what we can say, tensile stress is acting in a circular cross section at point B. At point, this is A and B. At point B, compressive stress is acting on a circular section. Is it right? That is a free body diagram of the torsional stress. Okay dear, again what we need to find? We need to find out the combining the stresses we need to find. Okay dear. So next one, we are going to learn about combine the stresses. Okay, at point A, is it right here? Then if you want to combine these stresses, then you have to represent as sigma x is equal to sigma A capital A. So this indicates that the axial stress is acting at A plus bending stress. The bending stress is acting at A. Okay dear, already we are discussing in the last problem dear. Sigma A value, axial stress acting at A value, we got it dear 4.58 plus the bending stress at A value, how much we got dear? We got the value of 20.53. If you add this whole the value, then you will get the answer of 25.11. Okay, how much we got in here? 25.11 Newton per millimeter square. That is the value of sigma x. Is it right? Again we have got the value of shear stress. How much we got here from the torsional stress? We got the value of 4.07. Okay, and shear stress value, the maximum shear stress value, how much we got here? 4.07 Newton per mm square. But in the equation of sigma y, how much is there? Because there is no biaxial stress is acting, like sigma x and sigma x only is acting, no biaxial is acting. Is it right in this case? So if it is no biaxial stress is acting, so this means that it is considered as 0. Okay dear, let us see. So you need to find out the maximum normal stress. If you want to find out the maximum normal stress, nothing but you need to find out the maximum principal stress. You need to find out the equation. Maximum principal stress. So sigma 1 equal to sigma x plus sigma y by 2 plus under root of sigma x minus of sigma y by 2 whole square plus tau xy whole square. Okay dear, let us see sigma x value is how much. Sigma x value we got it as a 25.11. You need to substitute in this equation. 25.11 plus sigma value is 0 because no biaxial stress is acting on this component. Is it right? For that reasons you have to consider as 0 by 2 plus sigma x value is how much? Sigma x value is 25.11, sigma y value is 0 by 2 whole square plus tau xy means shear stress is acting is how much is there? 4 point. So you can represent here tau or tau xy also. Is it right? Shear stress is acting. So what we can say, how much well is given? 4.07 whole square. So if you calculate this value with the help of calci, then you will get the answer is. So I am getting the answer is. So my value is 25.8 Newton per mm square. Again we need to find out the maximum shear stress. We need to find out. Okay, then maximum shear stress. Okay dear, we need to find. So how to find here? Tau is equal to plus and minus under root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, so plus and minus sigma x value is how much is it here? 25.11 minus of 0 by 2 whole square. Tau xy value is how much is that here? 4.07 whole square. So if you calculate this value, then you will get the maximum shear stress. Okay dear, so I am getting the value is 13.2. How much? 13.2 Newton per mm square. Okay dear, again what we need to find? Again we need to find out how much combined stress is acting at a point of B. We need to find out. Okay dear, at point B. Okay dear, if you want to find out means sigma x equal to, okay, axial stress is acting at a point of B plus, okay, bending stress is acting at a point of B. Okay, so how much axial stress is acting here? Axial stress should be same. How much? 4.58, but the bending stress is different. So bending stress value is how much is there? Minus 20.53. Then if you subtract this value, then you will get the answer is, so I am getting the value is 15.95. So what will be the unit will be there? The unit is Newton per mm square. That is the value of sigma x. Okay dear, again what we need to find? Again we need to find out the maximum shear stress. The maximum shear stress is same is there. Okay, shear stress value is how much is there? Shear stress tau value is tau xy, or we can say as tau value is how much is given? 4.07 Newton per mm square. Okay dear, then sigma y value, because there is no biaxial stress is there, so for that reasons you have to consider as 0 value. Sigma y equal to 0. Okay dear, again we need to find out the maximum principal stress. The maximum principal stress we need to find out in this equation. Okay, maximum stress or maximum principal stress is same concept will be there. Is it right? Again you have to use the formula is sigma 1 is equal to sigma x plus sigma y by 2 plus under root of sigma x minus of sigma y by 2 whole square plus tau xy whole square. You have to substitute the value. Sigma x value is 25.11. Sigma y value is here how much is there? 0. Okay, 0 by 2 plus under root of sigma x value is 25.11 minus 0 by 2 whole square plus tau xy value is how much is there? 4.07 whole square. So if you calculate this value with the help of calci, then you will get the answer is, so I am getting the answer is 0.98. Okay, so I am getting the answer is 0.98. The unit is Newton per mm square. Again we need to find out the minimum principal stress. Okay, minimum principal stress means minimum principal stress you need to find out. So sigma 2 equal to sigma x plus sigma y by 2. Here instead of plus we have to represent as minus under root of sigma x minus of sigma y by 2 whole square plus tau xy whole square. Okay dear, so sigma x value is how much is there? 25.11 plus 0 by 2 minus of under root of 25.11 minus of 0 by 2 whole square plus 4.07 whole square. If you calculate this value, then you will get the answer. So dear, once you calculate, so the value is minus 0.64 Newton per mm square. Again, what we need to find? We need to find out the maximum shear stress. Okay, maximum shear stress we need to find out. If you want to find out the maximum shear stress, what is the formula is there? Tau max equal to sigma under root of plus or minus sigma x minus sigma y by 2 whole square plus tau xy whole square. If you substitute this value, sigma x value is how much is there? 25.11 minus of 0 by 2 whole square, tau xy value is 4.07 whole square. Then you will get the answer is tau max equal to, so I am getting the answer is 8.95 Newton per mm square. If you observe this figure, where is the maximum principal stress is acting? The maximum principal stress is acting here is how much? 25 point here. Here what about at the point of B, the maximum principal stress is acting very less. Is it right? What about the shear stress? The maximum shear stress is acting as 13.2 Newton per mm square. What about at the point of B, the less shear stress is acting. So this means that at a point of A, the more maximum tensile stress is acting. At a point of B, the compressive force is acting. Okay dear, if you have any doubt, please mention in the comment box. Don't forget to subscribe my channel. Thank you.